Good afternoon. So I'm going to discuss an explainable AI solution, exploring the use of extended reality as a way to make artificial intelligence more transparent and trustworthy. This was written along with Dr. Carroll, as with Joel's previously. So some background. Machine learning and artificial intelligence have not only transformed the way we work, but also how many organizations operate. However, the benefits also come with challenges regarding project productivity and collaboration, as well as the need to explain how these systems work and how organizations interpret their output to achieve transparency and trust. This has become an important topic which can be addressed using explainable AI methods and processes. At its simplest, the purpose of an explainable AI system is to make AI and machine learning model behavior more accessible to its users by providing explanations for what a model has done, what it is doing, what happens next, and the information that it's working from. As previously mentioned, collaboration within these types of projects is also a big issue. A study from 2019 reported that 90% of its participants were manually tracking project steps using spreadsheets or even just handwriting notes. Also, when working on these projects, you have a mixed group of people with various skills and backgrounds, project managers, system integrators, developers, and most importantly of all, the end user. During COVID, we also saw a acceleration in the adoption of extended reality, with proof of concept projects being pushed into production to assist with remote working. Companies like Accenture have started giving new employees VR headsets, Oculus headsets, as part of the onboarding process, so that they can join in with virtual meetings. And just 3 or 4 years ago in my previous life, I was working for a company where we were exploring the use of virtual reality for operations tasks, HR kind of tasks like that. So the solution that I'm going to show you is a collaborative machine learning development platform. It's based on low code development, so no code is required, and allows for rapid development and experimentation of machine learning models. That's the back end. The front end for explaining how these models work is a virtual reality environment that enables collaboration and, as I said, to present the output of the development platform. When put together, both these systems allow the user to prepare and analyze data for machine learning model development, gain insights into data through visualization, select and compare multiple machine learning models, train and hyperparameter tune the selected models, analyze model performance, view experiment steps, and download all the assets created for use in further development, testing, or integration. And most importantly, present the models using an explainable AI methodology. I'm about to show you a short video that kind of walks you through this solution, going from the development of the model development through to presenting it on as within a VR environment.
In the rest of this video, we're going to look at an existing project developed using the application for a classification model that predicts mortality caused by heart failure. Within the data analysis section, the user has access to the application's data configurator, which enables them to make changes to and create new attributes from the original dataset in order to prepare it for use in developing a machine learning model. To assist the user further, this section also contains data reports showing both the statistical data for each attribute within the dataset, as well as the correlations and interactions between those attributes. The application also generates a selection of visualizations created from the dataset, which can be used for further analysis. Once the data has been prepared, it is then passed on to the machine learning model development section of the application. Within this section, the user is able to configure a number of data pre-processing options that will be used as part of the AutoML development environment. The application will then generate a data report comparing the training test data that will be used for modeling, along with a model comparison table showing all the models that were trained and tested, including performance metric scores for each. The application uses this AutoML environment to train and test a number of machine learning models from multiple libraries, including scikit-learn, XGBoost, LikeGBM, etc. The model with the best performance scores is selected and hyperparameter tuned before a selection of visualizations are created for analysis of the model's performance. The user is also able to change the selected model to any of those shown in the model comparison table, change the metric by which the model is optimized during hyperparameter tuning, or select an ensemble method for improving performance. Finally, the user can review the performance of the model by viewing predictions made using unseen data that the model is not trained or tested on with during its development. When the user is happy with the final model, they can then move on to the Explainable AI section. Machine learning models have been described as black boxes, where it is not always clear how they generate their output. This section uses SHAP plots, shapely additive explanations that are generated using the unseen data predictions to explain the model's output and the effect that the data has on how those predictions are generated. The final section within the application is the project log, showing each change the user has made either during data analysis or model development, for example, configuration changes during data analysis, and final model descriptions, including parameter settings and accuracy scores on the unseen data. From here, the project files and the final model can also be downloaded. All of the project files are also saved locally on the server so that they can be accessed again at any time within the application, as well as being prepared for use within the collaborative virtual reality environment. This VR environment was developed to enable project teams to analyze, discuss, and make changes to the model without requiring them to have local access to files, programming knowledge, or to even be in the same location. This proof of concept environment consists of 2 rooms split into 4 sections. Room 1 contains all of the assets created as part of the data analysis, including the full project log, both the original and final modeling data, the final suite viz and pandas profiling data reports for that modeling data, and all of the generated data visualizations. In the second room, all assets created as part of the model's development, including the AutoML environment configuration, the model comparison table, and the final model's tuning scores. A suite viz data comparison report for the training and test data used for model development, and all of the visualizations generated for analyzing the performance of the final model. The final section in this room contains the Explainable AI visualizations, including a summary of the importance for each attribute within the data on the final model's predictions, and the unseen data predictions, along with related force plots for the first 10 predictions, showing exactly how the data was used by the model in generating its output, and a full explainer plot showing the same force plot data but for every instance within the unseen data. As we return back to the original room, there we are able to see the final section where users are able to access the web application. From here, as described previously, they are able to make any changes that are required to the project.
The initial evaluation of the final solution was conducted using two methods. A presentation of the solution within a focus group setting, including a questionnaire to be completed after. There was also a video presentation, part of which you've just seen, accompanied by a short questionnaire that was posted on various social media platforms. The focus group aimed to collect feedback on the usability of the solution, its potential for improving a user's understanding of machine learning model development and explainable AI, as well as their opinions on how this solution could be improved. The questionnaire was used solely to further inform the findings from the focus group, with the following questions asked: to rate the overall usability of each of the two elements of the solution, both the web application and the VR environment; to rate the value insight into machine learning model development and explainable AI achieved using the solution; and to rate the potential of the tool for effective decision making on a project on a scale. The response to these questions was very positive, mean ratings for each of them scoring between 3.5 and 4. There was also a lot of positive discussion during the focus group. Some of the quotes here: you need a tool like that at the front end when you're scoping something out. You need to get a feel for what's going to work, and spending days and days coding solutions is not ideal to get that kind of information. Once you know the path, then that's time to go deeper on it. And this could have commercial applications where analytics are leveraged in consumer products, for instance, in digital marketing. The big problem they have here is how to communicate these complex ideas with clients. A tool like this could be used to help them understand the impact of different options and strategies for their business, and to fully understand the impact of their investment. For the video presentation study, a 7.5-minute long video was created that included a summary of the background and aim of the study, a walkthrough of the web application and its functionality, and finished with a demonstration of the VR environment with assets from the complete project. The accompanying two-question questionnaire consisted of both a single and open-closed question to rate the overall usability of each of the two elements of the solution, and a request for participants to leave any feedback they may have after watching the video. The response to the first question was again very positive, with mean ratings of between 4.25 and 4.5, and some of the feedback included this one quote: scaling back on coding makes it all look a little bit less scary and a bit more simple. The data is presented in a straightforward and easy to use web application in combination with the virtual environment, and is easily imagined being deployed within the business. This research has opened up significant opportunities for the design of explainable AI systems in an attempt to remove some of the complexities of machine learning model development. It has shown a method of explaining machine learning model development and how one can analyze model performance and then interpret the output through the use of a virtual reality environment. With the potential for multiple users to simultaneously use this solution to discuss and present the output from the development of these models, this highlights the affordance for collaboration and the value for transparency and trustworthiness. In the initial evaluations of the solution using both the focus group and video presentation study, we have also shown participants' responses were very positive and arguably very enthusiastic regarding its potential. The next steps will be to run a larger and more extensive study to probe how this solution and its usability affords greater transparency and trust within multi-user scenarios. In conclusion, we have embraced the challenge of making AI functions, workings, and results comprehensible for both development teams and, more importantly, the end user. And in doing so, have taken the first step in paving a path for combining explainable solutions and extended reality. Thank you. Any questions?